Theoretical scientist. So really quickly, I did notice that this previous assignment, level 3 for week 4, temperature and energy, was one of the assignments that I got some messages and to not only get some help, but potentially have more time to work on this. So I'm making this decision so that we're not going into Thanksgiving break with too much work. I'm actually going to allow this assignment to be still turned in throughout this week. This is week 5, right? So we're not going to have a level 3 assignment as long as we keep up to everything we're doing during class, but also making sure we turn this assignment in. Now here's the other thing, right? And this is one of the reasons why I'm making this video, sending it to y'all, making sure you can watch this to complete that level 3 assignment. There is a bit of math that we haven't looked into as a class. I believe that it's, for the most part, if you follow along with the example problem that we're going to solve together, mostly just multiplication and division. There are a couple units there, and I'll be explaining how that changes things. And at the end of the day, if you can just approach this through math, multiplying, dividing, isolating a variable that we don't know, you should be okay with not only some of the problems throughout this assignment, but the stuff that we will be doing later on. Again, this assignment is supposed to be an application of what we've covered so far. We've talked about energy going up, energy going down, right? Temperature changing and how that translates into energy. This is the connection to that. So this is how we look at it in the lab, where we start measuring things and start thinking, okay, this is how much energy is happening, how we can start comparing it depending on the substances. I know it sounds like a lot, but at the end of the day, we're just fleshing out the details of the things we discuss in class. And you might be wondering, why are we doing this math on our own time? This is my way of kind of making sure to remind you all that you can always reach out to me. I message students on mine all the time completing assignments, so I definitely don't want you to feel alone in doing some of this math. There's office hours as well that you can come to. Again, I know some of y'all I'm waiting on tomorrow, but at the same time, I want to really focus on the concepts we covered in class. If you're able to understand everything in level 2 assignments and really just understand the relationships, how things are moving, right, the connections between thermal, kinetic, energy, that's where I want you to be. This is going to flesh out the details. It's going to make your understanding of those concepts much more better. But I'd rather you focus on those in our time together to get the most support. And the math, while important, especially later on in the year, I want you to understand that this is an application rather than the math is kind of like the science. I know I'm talking quickly, but I'm hoping that this is just giving you some understanding of what this assignment is supposed to be about, and of course additional support, which we will start right now. All right, so this is part 4, where we start looking into something called heat capacity. I'm going to decipher these things as they go along, but I just want to point out that we were going to be working on question number 3 for this problem specifically. Let me just go ahead and read the question before we go into some definition, some of the stuff that you see up here. So question number 3, how many degrees does temperature increase when we add 24J of heat energy into 5G of water? Okay, from the get-go, although there's a lot of things, a lot of letters there that different words that we're trying to relate and whatnot, let's focus just on this question to see 2 things. 1, what do we already know about this process? And 2, what are we looking for? This tells us where we're going to be starting, and then eventually, of course, where we're headed. Why are we focusing on all these different things? What are we trying to connect to get to what goal? And it's really easy to kind of, well, I try to make it easy for y'all to understand where we're going. How many degrees does temperature change, the temperature increase, right? Being that question, right, that we're focusing on. How many degrees does temperature increase? We know that we're looking for some type of temperature increasing. And this is where I'm going to focus on our equation over here. This equation is simply, again, after some scientific explorations, how energy is related to 3 things. Amongst those 3 things, right, mass, which is just, you can think of stuff, right? I weigh, a certain amount of pounds. Things weigh a certain amount of grams. It's a different way to measure like stuff, like their weight, you can think of for now. And it's always going to be in grams, which is denoted by this G. We're going to go back to our question one more time to find where that is. There's also this triangle T. Now I'm going to call it triangle T for now. Official term is delta. All you need to know is that when you see this triangle, you're thinking change. You're thinking either a change in whatever it is. It could be temperature, it could be speed, it could be distance. In this case, it is T, which is temperature. And of course, we're measuring in Celsius degrees. So this, in fact, is what we're looking for, that delta T. That's what we're going to try to find out. A couple of other things. There's the specific heat capacity. And again, there's a little paragraph there that I'm not going to read. I'll let you read. That basically saying this is the rate at which 1 gram of a substance goes up by 1 degree Celsius. This is how much energy you need for that to happen, right? So when we look into the units here, for example, that of water down here, this is the C value. This is telling us that 4.186 J's, we'll go into that in just a second, gives us, right, it increases the temperature by 1 degree Celsius. So if something is at 0 degrees, 1 gram of water is going to increase by 1 degree Celsius. And obviously, the more grams you have of water, the more energy you'll need. The more you want to raise that temperature of 1 gram, the more energy you'll need. But it's a relationship. It's telling us this is the amount of energy you need. Okay, it's a little conceptual. Let's go ahead and apply it in a second so that hopefully it feels a little better. Now it's the final thing, energy. For now, we're just going to think of this in terms of joules. And we can go into that definition much later. In fact, we can do it in physics. But right now, you just need to know that it's a way to measure energy. Just like, food might have calories. That's another form of energy, right? It tells you how much energy, a specific type of food has. Joules is just a different type of way of measuring it. There's Celsius, there's Fahrenheit, there's joules, and then there's calories. For now, we're using joules to relate everything. So all of this information in, right? E equals mass multiplied by the specific heat capacity multiplied by the delta T. All of that covered. Okay, now let's go back to question number 3. How many degrees does temperature increase? So we're going to be looking for some type of delta T is what we know, right? Some type of triangle T, right? What is that triangle T? When we add 24J, that's 24 joules of heat energy. 24 joules of heat energy, okay, and there's the word energy there that also gives us a clue, into 5 grams of water. And I always like to ask what do we know, because it just gives us, okay, we're not starting with nothing. We know for one thing that energy, right, that the energy tells us that E is equal to 24 joules. 24 joules of energy. And we do have a quantity, we have an amount of water that we're using. In this case, it's 5 grams of water. This being, once again, we see a G there, that tells us it's a mass quantity, an M quantity. What else do we know? We also know that this is water. And at first it's like, okay, what's special about this? Remember that we're looking for the rate at which it heats up. And our paragraph here tells us that the C of water is this quantity. We're going to deal with the variables. I know they can look a little confusing all over the place. We're just going to write it out. C is equal to 4.186 J over grams Celsius. Okay, put a little dot there to multiply. But we're going to deal with this as it comes. It looks a little complicated, I promise you. Things will become much simpler once we start multiplying those things together. Okay, now we can just go ahead and put this into our handy dandy multiplication equation up there. E is equal, once again, to M times C times that delta T, which is what we are looking for. Triangle T, that's what we're looking for. And we're just going to go ahead and plug those numbers in. On our left side, we have 24 joules, right, is equal to what? To 5 grams multiplied by that rate, that 4.186 with a J on top and a gram in the bottom, as well as a degree Celsius. Okay, multiplied again by what we're looking for. We're just going to leave that as a triangle T for now. and we're gonna get to it in a quick second. Now, once we have everything laid out, we can do a couple of things. One, we can definitely start to isolate that triangle T. Whenever we want to find something we don't know, we want to leave it by itself just so that we know everything else. We can do all the math on one side so that on the right side it gives us our answer. What we're going to do to start off is notice that there's a G here, there's a G in the denominator. We can think this is a G over 1. And anything over itself, 1 over 1 is 1, right? 10 over 10 is 1, 1 million over 1 million is 1. G over G, as is the case when we multiply, we put it all together, is going to give us 1, which means we can cancel them out. All it means is that they're becoming 1, right? And then what we're left is just simply 5 times 4.186. Let me actually go ahead and pull out my calculator so we can do this multiplication together. All right, we're multiplying 5 times 4.186, which gives us 2093 on our values over here, and we're left with a J at top over a degree Celsius at the bottom. Okay, so we're good to go. We still have that, delta, the triangle T on the left, on the right, and on the right we still have our 24 joules, 24 joules. Whoops, all messy. Okay, now we still need to isolate this T, right? So what we can start doing is, once again, think about what we need to do, right? This is being multiplied by that triangle T. So in order for us to undo that, what we can do is simply divide. Anything over itself is 1. 1 over 1 is 1. 100 over 100 is 1. 20.93 J over C over 20.93 J over C. All complicated. This is still canceling out to 1. This all equals 1. Anything over itself is 1. But we have to do things on both sides of the equation. So yes, this lays out simply over here. All over here on our left, though, we gotta write it out one more time and do a little bit more math. Okay, so we have that on our left side. Our right is conveniently now just equal to triangle T over here, but on the left side we definitely need to start working out some math. 24 over 20.93, 24 over 20.93, 24 over 20.93. Let's go to our calculator here. 24 over 20.93 gives us a long number, and we'll simplify to, I see 4 values, 1.147. 1.147, right? J over J, I see 2 J's in the numerator, so those cancel out to 1. And then that thing in the bottom. So if you can see that, like over here, it's small math little thing, but you can see that this is kind of like 1 over C, right? But all of this is over a numerator. This just gives us its reciprocal. So we end up with C over 1 because it flips around. All of this to say, right, that this eventually becomes just degrees Celsius. And look at that, we're looking for a change in temperature, and just to double check, I'm gonna go and scroll up here. Our temperature change should be in Celsius. Given that it is in Celsius, in fact, then we can kind of be pretty confident that this is the temperature change. The question asks once again, how many degrees does temperature increase? We know that after adding 24 joules of heat energy, you can think of this as a little fire with that amount of energy, into 5 grams of water, will increase that water by 1.147 degrees Celsius. You measure at the beginning, before heating, you measure it after heating. That should be the temperature increase of those 5 grams of water. This is how we're relating everything as we look into those other problems, right? The other ones should be a little simpler, but ultimately this is what it's about. It's just putting those numbers together to see, we don't know one thing. What is that one thing after we account for all the other things we do know that we are given, that we can solve for? Hope that helps, and if you have any more questions about anything, do not hesitate to reach out.